All right, this is Coach Ledbetter. And so today's I'm going to do a video on rational numbers. All right, so we're going to do some notes here and just kind of go over this a little bit. All right, so a rational number, all right, if you look right here, a rational number has the word ratio in it. You see that. And if you remember ratios, when you did these some time ago, there were three types. There was one that said one with two colons and a three. And I'm just making up the numbers 1 to 3, or you could have it as a fraction 1 to 3. Okay, so ratio or rational numbers, and this is what our lesson's about, is a number that can be written as a ratio. All right, and we consider this like a fraction. So our ratios can be written up as a fraction. So if we can get it to look like a fraction, any number, then we consider it as a ratio. And we're going to say a fraction of two integers. I mean, it could be two negative integers because two negatives make a positive, or two positive integers. All right, so here's some examples of rational numbers. All right, so we're going to kind of do a little different here. So kind of watch this. So example, well, there you can see that good. So 2/3 is a rational number because you see the fraction, it's a fraction. All right, what about the number 5? Number 5, a whole number, any whole number, you can put a 1 in it and it's a rational number. All right, what about the square root of 4? Well, square root of 4 is really 2. All right, so that'd be 2, and then it'd be 2 over 1, which is a rational number. So, I mean, what you want to do is you want to try to find when you have a number, you want to find out if you can make it into a fraction. If you can make it into a fraction, or manipulate it where it looks like a whole number and can still make it a fraction, that'll work. All right, so we're going to talk about the different types of rational numbers. All right, we have several different types. The first one we're going to talk about is a natural number. A natural number. Or numbers. All right, so here's the definition. It's a set of counting numbers. That's all it is. It's a set of counting numbers. So how do you know what a counting number is? Now think about it. If I told you to count something, like these 3 pins here, and then so I can look at them. We'll put a couple more here. So if I have these pins here and I say, hey, I want you to count this, then I'm going to say, okay, that's 1, that's 2, that's 3, that's 4, and that's 5. So natural numbers are counting numbers. And so here's an example. So an example is 1, 2, 3, 4, 5. And we're going to say this can go on forever, positive infinity. Natural numbers, remember, is also, it says right here, is a counting number. So if you see something that says, what are the counting numbers? That's a natural number. It's the same thing. All right, next one. Next one is whole number. All right. What is a whole number? A whole number is, and I'm writing here, a whole number is a set of natural numbers. Okay, so we have a set of natural numbers. Let me raise up my camera a little bit. All right, so a whole number is a set of natural numbers. So the way I usually tell kids how to remember this, so they don't get it mixed up with the natural numbers or the counting numbers, is if you look right here, there's the letter O in ho. The ho. Oh, that sounds weird. All right, so for example, you have 0 as your starting number, just like that right there. And then it's the natural numbers 1, 2, 3, 4, 5, and it goes on forever to a positive infinity. So the whole numbers, I finally said it correctly, the whole numbers have a 0 in it or an O in it. So that's how you can start, how you can identify which one has the zeros. All right. The next one is integers. All right, so we have integers. Integers are all the positive numbers and negative numbers. All right, and so all positive numbers and all negative numbers. All right, so what are some positive and negative numbers? All right, so here we go. So we're going to say negative numbers, and we're going to just do a 3. Negative, let me do a different color so you can see a little better. All right, so we got -3, -2, -1, 0, right? And then 1, 2, 3. Now, you can have it go all the way to a negative infinity. So it could be negative infinity all the way to 0, and then from 0 all the way to a positive infinity. Now, is 0 an integer? Well, it's part of the integer system. And yes, it's neither negative nor positive, it's neutral. So it is an integer. It's part of the system that we call integer numbers. All right, so let's look at the overall picture. And so here's how it really works. We're going to talk about, we have something called a system called real numbers. All right, so you have real numbers, and we're going to put this big box here as the real numbers. All right, and there are two types of real numbers. There are rational numbers. That's the ones with a fraction, which we have been talking about. And then there's ones that are called irrational numbers. All right, so rational numbers, and let's use a big circle here to kind of represent it, as that's what most people do. They represent circles or squares or something like that. So there's all our rational numbers. Okay, so real numbers consist of rational numbers and irrational numbers. All right, so the next one would be, let's say, is integers. All right. We got our big circle for integers. So integers are rational numbers. All right, so all integers are rational numbers. But think about it. I can make a -3. I can make that into a fraction by putting a 1 underneath it. All right, and so that would be a rational number. All right, the next one will be whole numbers. Whole numbers, or remember, are the ones that have the 0 in it. See the little O there? Whole numbers. And we'll put our little circle here for whole numbers. So whole numbers can be integers and rational numbers. So see how the circle's inside the integers and the integers inside the rational. So all whole numbers are rational numbers. All whole numbers are integers. And remember, whole numbers, if you look right here, are positive numbers, 0, 1, 2, 3, 4, 5. So that means it's only on the positive side. So when we say zeros are integers, they are integers, but they're the positive integers. All right. Next one is, of course, natural numbers. So the natural numbers are the counting numbers. Remember, the natural numbers do not have 0, but the whole numbers do. So these are very similar, except this one starts with 0 and this one doesn't start with 0. Remember, this is also counting numbers. So natural numbers are whole numbers, which are also integers, which are also rational numbers. So that's how that works. Now, irrational numbers, there are two things about irrational numbers. You can't make it into a fraction, and like there's two things. It never stops. So like pi, for example, pi is a perfect one. All right, pi is like a decimal. It's like 3.14, and it just keeps going, keeps going, keeps going. It never stops, and none of the numbers repeat. So if it never terminates, that means it never stops, and it never repeats a number. Okay, so like what do we mean by repeating number? So like 2/3 is the same thing as 0.6666, and it repeats. So we put a bar over there. It never stops, but it repeats. Where irrational are decimals that never repeat, and they go on forever. Some common ones are like the pi, square root of 5, square root of 3. I mean, just the square roots are good ones to do. But I just want to kind of show you that Then there are other irrational ones, but we're just giving you some examples. But this is the real numbers. So real numbers are both rational numbers and irrational numbers. All right. Rational numbers consist of integers, whole numbers, and natural numbers. All right. And then irrational numbers are numbers that never end. Otherwise, they never terminate. They keep going on forever. And they end up being, they never repeat. Okay. I mean, you could have a repeating number that even looks like this. Our decimal, and see how 1, 2, 3, 1, 2, 3 repeats. So you would put a bar over the whole thing. All right. And that is our notes on rational numbers.